Okay, this is MAC 1105, section 4.3. We're going to be looking at properties for expanding logarithms. As you can see at the top of the outline, there are quite a few properties that we've learned. And the very first one is the log of 1 with any base. Remember, that base has to be greater than 0, and that was from one of the rules from section 4.2. And if you put this in your calculator anyway, you would get a 0. So, these properties have been mentioned in section 4.2, some of them. The ones that are new are 3, 4, and 5, which are the emphasis of this section. This was the inverse property, that when the augment matches the base, whatever the power is here, which would be a 1, is what this is equal to. And then these are the 3 new properties from section 4.3. Okay, these were from 4.2, and these are the ones we're going to be concentrating on here. These properties are all about taking products apart, and also you can put them back together, because all of these, a lot of these properties that you're learning, you can use them forwards and backwards. You can go from a product and expand it into a sum. So the factors of the product, x and y, the things that are being multiplied, the factors, each one of them becomes a log in and of itself. So you would have log of x and log of y. So if you started with a product, what you're going to need to memorize is that it splits up into a sum. And depending on how many factors there are here will depend on how many individual log expressions you have when you expand it. But all plus signs between the individual logs when it came from a product. If it comes from a quotient, x divided by y, it'll be log of the top, that'll be one of your individual logs, minus log of the bottom. So the expression that is in the denominator, that's the one that will have the minus in front of it. Then there's also the property rule. So there's the product rule, the quotient rule, and the power rule. If you have log of x raised to a power of y, you actually have 3 levels here. You have the base, the augment, and you also have the exponent. The exponent swings out front and becomes a coefficient of the log. And then you leave the augment in place and the base. That's the power rule. So these are the 3 properties we're going to be using as we go and do these problems. For instance, in number 1, it says use the properties that you've just gone over here. When possible, evaluate the log expressions without using a calculator. That means simplify if you can. So this is a product. That means that when you expand it, you're going to expand it using a plus sign. Products become sums. So this is going to be log of 3, that is one factor of this product, plus log of 7. And whatever the original base was, 6 in this case, those will be the bases on the individual logs. Neither one of these simplify. I mean, if I could use the inverse property, I would use that to simplify, but they can't be simplified. You're going to see that as you get deeper into this section, it'll be a mixture of these rules that you see here, these new rules. This was just the product rule. Okay, so that's what I applied there. Okay, in the next problem, again, it's the product rule. But again, you're going to have to look after you expand it, can you simplify it? So this would be the log of, here's the 2 things that make up the product, the 343 and the x. That's what that says, 343 times x. So you're going to take it apart using the factors that are in the product. 343 is one of the factors, and then the x is the other factor. Started off with a base of 7, and therefore both of these are 7. The only thing is that this one can be simplified further, because log of 343 can be written as log of base 7, and then 343 is 7 to the 3rd. So you should look at the base that you have here and see if you can write this number as that base to some power, which you'd have to fiddle around in your calculator with it. This you can't do anything else That's going to stay like that. But right here, when the augment matches the base, they take each other out along with the log, and the exponent is what this entire expression simplifies to. So in the end, this answer is 3 plus log of x base 7. Okay, so again, that was the product rule. So I used the product rule to expand it, and then I used the inverse property from the previous section. In order to simplify it further. Okay, this is the quotient rule. You're starting off with a quotient, so that property goes log of the top minus, you use a minus when you're breaking apart a quotient, minus log of the expression in the denominator. Both of these were base 6, so these are base 6. Again here, the inverse property applies. Since the augment matches the base, these cancel each other and take the log with it, and what this is equal to is whatever this power was, which would have to be a 1 since there's no power. So this is equal to 1, and then this term you can't do anything with. So I use the quotient rule or quotient property, and I used and you're going to see the inverse property is used quite a bit in order to simplify. Okay, here again, it's, oops, wrote that too soon. This is the quotient rule again. So it's log of the top minus log of the bottom. Put that base in there. The base will tell you how you should rewrite anything that's all numerical. So I'm going to see, could I write that? What could I do with that in order to get a 64? So 4 squared is 16. 16 times 4 would be 64. So I'm going to rewrite this as, and you can just do it in your calculator. One way to write 64, because I wanted to purposely use this same number or else I can't get the inverse property to work. And sometimes you can't. But 4 to the third is 64, and being that I chose to rewrite 64 this way as opposed to, like, let's say 8 squared, I have the inverse property working. Those take each other out, and they leave, they take the log with it, so that this is just equal to 3. This expression you can't do anything with. So in the end, the answer is 3 minus the log of y, base 4. That's your final answer. And again, I use the quotient rule, or the quotient property, and the inverse property here. This was your final answer here. This was your final answer here. Okay, here. It is natural log of e to the 8th minus natural log of 13. Now the natural log has no base other than the number e. So you can hang those right there. You got the inverse property working right here. When the augment matches the base, those two take each other out, take the word log with it. This just happens to be a natural log, and whatever's in the power position is what this entire expression simplifies to. And then this, you can't do anything with it. And you have the option, if you know you can't simplify it, of either putting the e there or not. But again, the natural log can have no base other than e. Whereas log, you can find that in various bases. When you do see this expression, but without a number there, then it's said to be a 10. But otherwise, they'll state the number. Okay, so that is your final answer there. For this one, you have a power going on. So what we're going to do is rewrite this. We're going to bring the power down in front. So it's 4 times log of x. And then the base that's there, I know that's pretty tiny. have to enlarge those problems, but it says log of x to the fourth with a little hanging base of t. That's what it says originally. But that's all you can do. Nothing matches here, so you have to leave it like that. So this was the power property. This one was the quotient property. And then the inverse property allowed me to cancel those. So I used a lot of these. I've used two properties in one problem. Okay, this one. You're going to want to write this in power form. So first of all, reviewing what I said about how to write a radical in power form. Inside, this is x to the first degree. So if you want to write this in full power form without the radical, it's natural log of x to the, there's one of those x's occurring, over whatever the index is. It's a little number sitting on the radical. So all radicals, when you write them in power form, the power is a fraction, the exponent's a fraction. Okay, the only thing that you can actually apply here is the power property, and that's where you take the power and it becomes the coefficient. So this will be natural log of x. The 1/13 is out here now, and it's not. And if you don't see that anything's going to cancel here by the inverse property, then you really don't need to put the e there. You can if you want to. This is 1/13 times natural log of x. Okay, here it's log base b of this product. So first I'm going to take the product apart. I'm going to go log of this factor, y to the fifth. It's a product, so I'm using the product property, meaning you use a plus sign. Every time you're doing a product, you take it apart with a plus sign, and when you see a quotient, as you've seen in these three examples, you take it apart with a minus sign. So now the other part would be log of z. Both of these had a base of b, so I'll go ahead and put that there. And then on this piece right here, you can still do the power property. So you can swing that out front. That's going to be 5 times the log of y base b. And then this will be log of z base b. And that's it for that one. Let's move on to the next page. Okay, working with number 9. Problem number 9, use the properties to expand, evaluate the expressions without using a calculator if possible. In other words, simplify if possible. So first thing I'm going to take apart is the quotient. So I'm going to take the quotient apart with a minus sign. So it's log of the top minus log of the bottom. Now that bottom that you're seeing right there, that can be written in power form. Any radical can be written in power form. This expression, x plus 5, you see one of them. There is one of those underneath that radical. So that can be written as x plus 5 to the 1/2. The index for a square root is said to be 2. Okay, so this is the log of x plus 5 to the 1/2. That's the power. Okay, so I've split up the fraction. This radical down here, square root, where the index is 2 and the power on this expression x plus 5 is 1, can be written in power form as x plus 5 to the 1/2. That's why I wrote it like that, because then it has a power, so that then you can apply the power rule. It didn't have a power while it was in radical form. The base on both of these is 5, so I'll go ahead and put that there. In this particular case, you're going to be able to simplify further on this first term because 125 can be written using 5s. It is 5 to the third. And whenever you can rewrite the argument in a manner that its base matches the base of the log, these cancel, taking the word log with it. and the exponent is what it simplifies to. There's no way to write this in terms of just fives, so all you can do is just bring that down into your final answer and leave it like that. And at that point, when you know that you are not going to be able to use the inverse property, you could at least take the exponent and use the power rule. This is a power or an exponent. You can write it either way. So you always want to take that power down so that you're not giving anything in your answer that has a power any different than just 1. So see, now the power is 1. Okay, so here I applied the quotient rule or quotient property. And then, so I'm not leaving any powers other than 1 on anything. I took this power and brought it back down. So that is the power property. And that's all you can do with that. Okay, here there's quite a few things. I'm going to take the quotient apart first. Always take the quotient apart first. So it's log of the top minus log of the bottom. Okay, the top has a product, is made out of a product, x squared y, and the denominator is z squared. Both of them have a base of b. Then I'm going to apply some other properties. Okay, another thing that you could apply here is you could take this product apart using plus signs. So going further, this would be log of x squared plus log of y as you take the product apart. Still both with a base of b. Minus, this is, the only thing you can do to this back piece is bring the power down. You can bring the power out here, applying the power property, and it would just be log of z. Still with a base of b. So you can't do anything further to that. Everything in the argument has a power of 1, but you can do something further here. You could take this power down. Bring the power out front, final answer. The 2's now out here with just log of x, base b. Then there's just log of y, base b. And then there's minus 2, log of z, base b. Okay, then going on to number 11, had to take a little breather there. Now you're going back the other way. Here they're saying use the properties to condense. That means bring it back to a single log. So now you're going back the other way. Okay, so if this is a plus sign, that means it used to be a product. So going back to just a single log, meaning you should only see the word log, whether it's natural log or log, one time. And then because there's a plus sign in between these two individual logs, that means that these two things used to be part of a product. In other words, multiplied. So there you go. Whenever it's ln and there's no base mentioned, it's said to be an e, and you have the option of leaving it off or putting it on. I would put it on when you know that it's going to help you achieve the inverse property. That's not going to happen here, because if you put an e here, you don't have an e here that's going to cancel with it, so it's not going to do anything for you. So that's the final answer there. This was the final answer here. This was the final answer here. Okay, moving on to 12. This one has a minus sign in between these two individual logs, which means that it used to be a quotient. So here I was using the product property, bringing it back to a single log. Here I'm using the quotient property, bringing that back to a single log. So this is going to be log of 48 over 8. Because one was log 48, one was log 8, and this is base 6. Continue working with that. 48 divided by 8 is the same thing as 6. Base was 6. Final answer, 1. When this matches this, they take each other out with the log, And this entire expression is equal to whatever this power is, which was a 1. Okay, so that's your final answer there. Then, number 13. Okay, you have a minus sign here. That means that this used to be a quotient. So I'm using the quotient property here. This would be log of, let me get my quotient ready. When there's no base on this, the base is said to be 10. You can put it or not, but quotient, the 4x would be the top. You can put that in parentheses, and then the x, only one term, you don't have to put that in parentheses, would be the bottom. And you can either put the 10 there or not. It is said to be a 10. We know that it's a 10 when you don't write anything there. Otherwise, it would be a number there. So for 13, you're done. 14, moving on. I see a plus sign in between these individual logs, and there's more than one thing going on this second term. So I might take these coefficients and swing them back up to where they used to be. So when you go ahead and make a product here because of the plus sign, it's log of, okay, we're going to make a product of the y that you see here and the z to the 9th that you see here. We're going to multiply those two things together. One's a y, the other one is z to the 9th. So you're putting it back in condensed form, seeing the word log just one time. Okay, we made a product because of the plus sign, and that coefficient of 9 went back up to where it used to be, and that's into the power position. Number 15. 15 used to be a quotient. So it's bring the power up first. I would do that just so you realize that's where it used to be. This one also has a power, used to be a 9. But there is a minus sign here. And if there's a minus sign, that translates into a quotient when you're talking logs. Okay, so a single log, we're going to do a quotient. And the quotient is made up of, the top would come from this first expression. So x plus 9 squared. And then this would be the expression that's in the bottom, whatever comes after the minus sign. So that would be x to the 9th. And then when you don't put any kind of base, for a natural log it is said to be an e. You can put the e there if you want or not. Okay, moving to number 16, which is our last problem here. There's quite a few things you have to do here. I think I would bring the coefficients up first, just so you remember that this really used to be x to the 6th. This one used to be y to the 3rd, and this used to be y to the 4th. You don't bring the negative with it. The negative just means you're going to be doing a quotient. So all these things had powers. This 6 is now up here on the x, the 3 is now up here on the y, the 4 is now up here on the z. And then you're going to put them together into just one single log. Okay, things that are separated by a plus sign means they used to be a product. So it's a product of x and y. X belongs to the first log, y belongs to the second one. So a product out of those two, because there's a plus sign between them. And then anything that comes after the minus sign, oops, and I forgot to put the powers on. It was x to the 6th, and it was y to the 3rd. Anything that comes after a minus sign, that means it belongs in the quotient. And there was a z with that log, z to the 4th. So there is all of those things in position. All of these front numbers, coefficients, came up and became powers. That's why you see everything with a power. There was a plus sign right here. And so because there's a plus sign between these first two expressions, they are part of a product. And since this last expression comes after a minus sign, that means it was part of the quotient. Okay, and that completes section 4.3.